All right, hello people. Now I know you've been there. You just get so mad at your family, you just want to take the pizza and throw it on the roof. Only problem is, you don't know how far it went. Let's figure it out. So, let's try it out. So we got our picture as always. We got you over here. Oops. You're mad at your family, and you're gonna throw the pizza onto the roof. Now we know some information. I know that the roof is 6 meters tall. Um, and you're going to throw it at an angle of 60 degrees. And we know that you are 6 meters. Is it 6? Yes, 6 meters from the roof. So 6 meters tall. And then we know, of course, that we throw it with a velocity of v naught equals 30 meters a second. Okay. So my drawing here is kind of deceiving. It's really being thrown from the ground. Imagine that you are 0 inches tall. So you're throwing it basically right from the ground up here. Another way to think about it, this roof is 6 meters taller than the top of your head. Okay? So, um, first things first, for these problems, I think the best thing you can do is to express x and y of t for the object in question. So x of t is usually the easy one. X of t is just going to be, Gordo, get out of here, is going to be v naught in the x direction times time. And now I have to talk about where I'm going to put my origin. So I'll put my origin right here. X and y. So my origin dictates that I'm starting from 0, and there's not going to be any acceleration in the x direction. So this is going to be my entire x of t term. And solving for it, I will get 30 times the cosine of 60 times t. Now I know where this thing is for all time. You give me a time, I'll tell you where it is in the x direction. Now let's do the same thing for y of t. So where I've set my origin, y of t is starting at 0. And then it's going to be plus v naught in the y direction times time. And then, of course, minus gt squared over 2. Because gravity is an acceleration term, and it only acts in the y direction. So we don't have any acceleration in our x direction. So plugging in some numbers here, I will get 30 times the sine of 60 times time. And then you know g equals 9.8. So I'm just going to leave that as is. Okay, so now we know x and y of t for all time. So what we're really after is this distance, right? We want to know how far onto the roof does the pizza go. So we really need to figure out, where is this thing? What is the x position of the pizza when it stops flying? So what do I mean? We need to know the time of flight, which I'll call capital T. And what do we know about this time of flight? Well, I know that at y evaluated at this time, it's at a height of 6, right? Because when this thing stops flying, it will be at a height of 6. Now you'll notice there's actually kind of 2 times, at least in general, where this height could be equal to 6. On the way up, and then on the way down. So at the end of the day, we'll probably get 2 answers for a time, and we're going to want the greater one. So let's plug in this condition, all right? And the idea is we'll solve for the time, and then plug that information into our x and that'll give us where this pizza is at that time when it stops flying. So I do y of big T equals 6 equals 30 times the sine of 60 times big T minus gt squared over 2. Moving everything over to one side, I'll get 0 equals negative gt squared over 2. And then let's just evaluate that. 30 times the sine of 60, I think that's 15. No, not quite. Plus 25, I'll call it 26. T minus gt, or I already got that, minus 6. So just reorganizing this equation so everything's on one side. 26t is the velocity term. So now we do our quadratic equation. Whenever you see an equation like this, where you have something that looks like this equaling 0, then we do our quadratic. So this will be negative 26 plus or minus the square root of 26 squared minus 6 times g over 2 times 4. It's my 4ac term. And this is all over negative g. Okay. So what do I get? I'll get, so let me figure out that square root term. 26 squared minus 6 times 9.8 times 4 divided by 2. So I get, and then I don't want to take the square root of that. So I get negative 26 plus or minus the square root of 4.86 divided by 1, or no square root, I already did the square root. Plus or minus 4.86, all divided by negative 9.8. So this gives us 2 times. I get negative 26 plus that answer divided by negative 9.8. I get 2.2, comma, negative 26 minus 4.86 divided by negative 9.81, 3.15. 3.15. Okay. So the time of flight, we want that greater time, because remember there's going to be 2 times when it's fulfilled, and we saw that here. We got 2 positive real times. And that is identifying the 2 points where it is equal to the height of the rooftop. So t equals 3.15. So then I evaluate x of t. And then I want this little distance here. So I'm going to minus 6. Right? Minus 6 from, because it's traveled 6 meters. And we want to know how far is it onto the roof. This point is x of t. That's x of t. So then to get this distance, I subtract 6. So x of t minus 6 equals 30 times the cosine of 60 times my time, which is 3.15. 30 times the cosine of 60, 15. And then minus 6. So I get 41.25. Okay. So we went through, we're throwing this thing onto the roof, and we started out by just writing our x and y coordinates for this pizza. And now the thing with these trajectory problems is going to happen again. You focus on one of these directions. In this case, we focused on the y. Use that to find our time of flight. And then, so we went through here, we came in, we saw that this was our time of flight, either 2.2 or 3.15 seconds. We chose the greater time, because that's what we want, as I explained earlier. And then I just evaluate x at that time minus 6. You get 41.25.